Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers error intervals or limits of accuracy. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 4. A number x is 15.8 when rounded to 3 significant figures. Circle the error interval. Okay, now I always find it useful to just quickly draw a number line, mark on the value I've been given. Now this number's been rounded to 3 significant figures, so the next one up from there would be 15.9 and one down from it would be 15.7. And the numbers that round to 15.8 are the ones halfway between. So halfway between 15.7 and 15.8 is 15.75, and halfway between 15.8 and 15.9 is 15.85. So all those numbers in between are the ones that round to 15.8. So our value of x is going to be somewhere in between these. Now 15.75 rounds up, so it's going to be included in the range x, and 15.85 rounds up to 15.9, so it's not going to be included in the range, so we use a strictly less than symbol there. So the one we're interested in is that one there. 15.75 is less than or equal to x, which is less than 15.85. Question 5. Paul won a race with a time of 71.3 seconds. This time t is the nearest tenth of a second. Complete the error interval due to a rounding. So if I've got a line and I've got 71.3, it's been rounded to the nearest tenth. So one down on the scale would be 71.2 and one up on the scale would be 71.4. The numbers that round to 71.3 will be halfway between those. So halfway between 71.2 and 71.3 is 71.25. And halfway between 71.3 and 71.4 is 71.35. So all the numbers between 71.25 and 71.35 are going to round to 71.3. 71.25, 71.35. In question 25, we've been given a formula S equals D divided by T, and we've been given the values of D and T correct to 2 significant figures. Now this question is about working out the upper and lower bounds for S, given our answer to 3 significant figures. Now, in order to do that, we need to know what the upper and lower bounds of D and T are. Okay, so D is 160 to 2 significant figures. Now, the second significant figure of this number is the 6, which means that D has been rounded to the nearest 10. Okay, now if we imagine a number line, oops, let's do that again. If we imagine a number line, and we mark 160 on that number line, then we're rounding to the nearest 10. So the other point I could have rounded to was 150, one below, and the one above that would be 170. Now all the numbers that are round to 160 are the ones that are closer to this number. So the lower bound is going to be 155 and the upper bound is going to be 165. So all the numbers in between 155 and 165 round to 160. Now for our second value, t has also been rounded to two significant figures. This time the second significant figure is that 2 there. It's 1/10 or 1 decimal place. Now if I do the similar sort of thing, if I draw a number line and I mark 7.2 and I mark either side of that the possible next two marks on my scale, so 7.1 and 7.3, we should be able to see that the numbers that round to 7.2 start at 7.15 and go up to 7.25. Okay, and then all the numbers in between that round to 7.2. Now when I take S, which is d divided by t, now my maximum value I'm going to get is if I divide my largest possible value of d, which is 165, and I divide it by my smallest possible value of t, which is 7.15, and that is equal to 23.07, which I'm going to round up to 23.1 to three significant figures. And my minimum possible value for S is going to be my smallest possible value of D, which is 155, divided by my largest possible value of T, which is 7.25. which gives me 21.37, which I'm going to round up to 21.4. So my upper bound is going to be the largest one of those two, 23.1, and my lower bound is going to be the smallest of those, 21.4. 23.1 and 21.4. Question 25. An empty container has a capacity of 80,000 litres to one significant figure. Mel pours in 7,400 litres of water to two significant figures. She says, I have filled more than 10% of the container. Is she correct? You must show your working. Now this question is about limits of accuracy. It isn't explicit, but the fact that you've got these numbers rounded off to one significant figure here and two significant figure here should be setting off those sort of alarm bells in your head that it's a limits of accuracy question. So let's take the capacity of the container first off. Now that has been rounded to one significant figure. So the first significant figure of this diagram is this 8 here. It's the 10,000 value digit. So if I was to draw a number line and mark on it numbers going up in 10,000s, I'd have my answer there at 80,000, and the next one up on my scale would be 90,000, and the one below it would be 70,000, and then the numbers that would round to 80,000 would be the ones that are closest to it on that number line. So more than halfway between 70,000 and 80,000, so our boundary there is 75,000, and at the other end less than halfway between 80,000 and 90,000, so less than 85,000. So there are upper and lower bounds for the capacity of the container. Now next it says Mel pours in 7,400 litres of water correct to two significant figures. So the second significant figure of this number is that 4 there, is the hundreds. So again I'm going to just draw a scale, and I'm going to mark on the value that they've given us, which is 7,400, and I'm going to mark one above it on our scale. If we're going up in hundreds, the one above it would be 7,500, and the one below it would be 7,300, and then the numbers around to 7,400, which would be the ones closest to it on the number line, all the numbers in here. So the lower bound is going to be halfway between 7,300 and 7,400, which would be 7,350. And the upper bound is going to be 7,450. Okay, so let's get on to the question that was asked. She says, I have filled more than 10% of the container. Is she correct? Now, to find a percentage, you're going to have to divide how much she pours in by the total. And we're going to get different values depending on whether or not we use the upper and the lower bound for each of these numbers. So I think what I need to do is work out the two limits of her answer. So to work out the percentage, it's going to be the amount she poured in divided by the capacity. So the lower bound of that, percentage lower bound, is going to be, well, I'm going to get that if I take the smallest possible amount of water and divide it by the largest possible size of the capacity of the container. So that would be 7,350 divided by 85,000, which is 0.086, which is 8.6%. Okay, now the upper bound, so the percentage upper bound, is going to be the largest possible amount of fluid that she poured in divided by the smallest possible capacity. So that is 7,450 divided by 7,500, which is 745 divided by 7,500. Now that one comes out to 0.099, which is 9.9%. So actually she's filled between 8.6 and 9.9% of the container. So has she filled more than 10% of the container? We can say no. John is drawing a quadrilateral. The length of each side is 5.2 centimeters to one decimal place. Complete the error interval for the length of one side. Okay, so I tend to do these with a number line to start off with. I mark the point I've been given, 5.2, and then I use the rounding amount to mark on my scale the next one up. So if I'm going up in one decimal places, the next one up on my scale will be 5.3. And the one below it will be 5.1, and then I consider all the values that are going to round to my given value. That's all the numbers that are halfway between 5.1 and 5.2 will round up. That gives me a lower bound of 5.15, and the ones that round down are going to be halfway between 5.2 and 5.3, which is 5.25. So they're my two boundaries of all the values that round to 5.2. So the length needs to be bigger than 5.15 and less than 5.25. Complete the error interval for the perimeter. So we know that each of the sides are going to be between these two ranges. So the smallest possible range of the perimeter is going to be 4 lots of my lower bound, and the largest is going to be 4 lots of my upper bound. So 4 lots of 5.15 is going to be 20.6. So 5.15 is probably a good idea to write down the calculation that we're doing. Examiner's not a mind reader. And then my next one, 5.25 times 4, is 20, it's just 21, isn't it? Okay, so my range is going to be 20.6 to 21. Question 6. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. Question 20. This sign shows when a lift is safe to be used. Total mass of people must be 450 kg or less. Ben and some other people are in the lift. Their total mass is 525 kilograms to the nearest 5 kilograms. Ben gets out. He has a mass of 78 kilograms to the nearest kilogram. Is the lift now safe to use? You must show you're working. Okay, now this question is a limits of accuracy question. You can tell that by these phrases here, to the nearest 5 kg and to the nearest kilogram. Okay, when you see those, it should be screaming out at you, limits of accuracy. So the first thing we should do really is think about what those limits are going to be for our two amounts here. Now we know that 525 kilograms has been rounded to the nearest 5 kilograms. So if we draw a number line and mark on the number they've given us, 525, and this scale is going into the nearest 5 kilograms. So let's mark one up on our scale, which should be 530, and one below on our scale, which should be 520. Now the numbers that round to 525 are going to be the ones that are nearer to 525 than the other two numbers. So anything more than halfway between those two numbers is going to round to 525. So what is halfway between those two numbers? Halfway between 520 and 525 is 522.5. So that's going to be my lower bound, and my upper bound is going to be halfway between 525 and 530, which is 527.5. Okay. For the other measurement I've given, the measurement of Ben, we know his weight is 78 kilos to the nearest kilo. So marking my scale one above at 79 and one below at 77, and using the same thinking, we know the numbers closest to 78 round to 78. So the lower bound is going to be 77.5 and the upper bound is going to be 78.5, and anything in between is going to round to 78. Okay, let's think about everybody in the lift. We've said that they must be between 522.5 and 527.5. Now let's err on the side of caution and consider them to be at the upper bound. Now obviously it can't be precisely 527.5 because that would round up to 530, but 527.4999 reoccurring would round down, so that's pretty much the same thing anyway. So we're going to use that as our worst case scenario, and let's assume that Ben is the lightest he can be, so him getting off the lift or getting out of the list is going to make the least possible difference. Okay, so then the worst case scenario then is going to be my heaviest group of people and my lightest possible Ben getting off. So 527.5 subtract, so our heavy group subtract our light Ben. What does that give us? That gives me 450 kg exactly. Now, the total mass of people must be 450 kilograms or less. So this is the upper bound of the weight of people. Any other case would be less than that, and 450 itself is acceptable as well. So all the possible values that it can be are at 450 kilograms or less. So we can say that the lift is now safe to use just. So the lift is now safe to use. Question 7a. The length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of pipe. Okay, well, if it's 6 to the nearest meter, then the next one up on the scale would be 7, and the one below it would be 5. And the ones closest to 6 then would round to 6. So the ones in here. Okay, so where does the boundary lie? Halfway between the two of them, 5.5 and 6.5. So we want our length to be greater than or equal to 5.5 and less than 6.5. Okay. Question 7b says the length of a different pipe is 4 meters to the nearest meter. Ollie says the total length of the two pipes is 11 meters to the nearest meter. Give an example to show how he could be correct. Well, we know that the first pipe is between 5.5 and 6.5. So let's say if one pipe is up towards the upper end of that range, 6.4, and the other is, well, it could be 4.4, couldn't it? So then 6.4 plus 4.4 is 10.8, which is closer to 11 than 10, isn't it? So yeah, it could be 11 to, what's that, two significant figures. Okay, so he's right. Question 8. Three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum of the original three numbers. And that's quite a confusing question, really. I think sometimes if it's not clear how to proceed, then perhaps let's just try and do some numerical answers and see if we can work out what patterns there are or what the underlining things are. So let's have a look. So three whole numbers are each rounded to the nearest 10 and they sum to 70. So let's say that my three numbers rounded are 40, 20 and 10. That would add up to 70, wouldn't it? Okay, so what is the maximum number then that would round to 40? Now remember, these are whole numbers, so they can't be like point anything. So the biggest number that rounds to 40 is going to be 44, isn't it? Because 45 would round up to 50. Similarly, 24, so the largest number that rounds to 20 is going to be 24, and the largest number that rounds to 10 is going to be 14. So if you add those up, you're going to get what? 4, 8, 12 more than 70. It's going to be 82. Okay, so that's one possibility. So let's just have another look at a different one. So perhaps instead of having numbers that rounded to 40, 20 and 10, we had a number that rounded to 30 and then two numbers that rounded to 20. Does that change anything? So that adds up to 70 again. So the largest number that rounds to 30 is going to be 34. The largest number that rounds to 20 is going to be 24, and the largest number that rounds to 20 is going to be 24. So again, that's like 4, 8, 12 more than 70, isn't it? So I think whatever combination of numbers that you pick that round to your original 70, your maximum possible number is always going to be 4 more than that 3 times. So 4 times 3, 12 more than that amount. So the maximum possible sum has to be 82. Make sense? Question 25. The dimensions of a rectangular floor are to the nearest 0.1 meters, 2.6 meters and 6.4 meters. Okay, so before we go any further, this thing here is telling me what type of question this is. This is a limits of accuracy question. So we're interested in the maximum minimum possible values, I think, for this question. Anyway, let's read on and find out the rest. A force of 345 newtons is applied to the floor. The force is to the nearest 5 newtons. So pressure equals force divided by area. Work out the upper bound of the pressure. Give your answer to 4 significant figures. You must show your working. Okay. So let's take our lengths and widths of our rectangular floor first off. It's to the nearest it's to the nearest 0.1 meters. So 2.6 meters, then the width. If I've got 2.6 on the number line, then 0.1 more than that would be 2.7. 0.1 below that would be 2.5. And then the values that are closer then to 2.6 are going to round to 2.6. Now they're going to be the values that are halfway between 2.5 and 2.6. So 2.55 is the lower bound and 2.65 is the upper bound. Okay, if I have a look at the length, do the same thing. 6.4 in the middle, one more would be 6.5, one less would be 6.3. So then the values that are going to round to 6.4 are going to be 6.35 is the lower bound and 6.45 is the upper bound. So then we're told a force of 345 newtons is applied to the floor, and that force is given to the nearest 5 units. So again, drawing 3, 4, 5. 5 units above it would be 350. 5 units below it would be 340. And the ones that would round to 345 are the ones that are going to be halfway between those values. So halfway between 340 and 345 is 342.5, that's the lower bound, and 347.5 for the upper bound. Okay, they're the ones that round to 345. Okay, so now I've got all my maximum minimum possible values. I can then go on and consider which ones I'm going to have to use. So we're told that pressure equals force divided by area. Work out the upper bound of this pressure. What's the largest possible pressure I can get from those values? Okay, so pressure then, am I going to use the largest possible force or the smallest possible force to get the largest possible pressure? Well, I think I need the biggest possible number on the top of this fraction if I'm going to get the largest possible pressure. So I'm going to take the upper bound of my force, 347.5, and I need to divide that by the area. So then the area, am I going to take the smallest possible area or the largest possible area to make the largest possible pressure? I think I need to, if you're going to divide, you want to divide by the smallest possible value to give you your largest possible value. So what's my smallest possible area I can get? That would be taking the lower bounds of my two sides of my rectangle and multiplying them together. That would give me my lowest possible area then. So that's going to be 2.55 times 6.35. Now, if you're getting confused or can't figure this out, you can just do the calculations multiple times with the various values and seeing which one is the biggest and the smallest. It might be worth doing that anyway if you've got a bit of spare time towards the end of the exam. It's a good way of checking your answer. So 347.5 divided by 2.55 divided by 6.35. That comes out to be 21.46. To four significant figures. 21.46. Interesting that they asked for four significant figures there. It's quite unusual. Okay, so that's my answer, 21.46. Question 9. The length of each side of a regular pentagon is 8.4 centimeters to one decimal place. Complete the error interval for the length of one side. Okay, so I always draw a kind of a scale when I'm doing these sorts of error interval questions, and I mark on the number they give me, and then I imagine the scale either side of it. So if this was going up in one decimal places, then the next decimal place up from 8.4 is going to be at 8.5, and the one below it is going to be 8.3. So then the numbers that round to 8.4 are the ones that are going to be halfway between those two, aren't they? So halfway between 8.3 and 8.4 are going to round up to 8.4, and halfway between 8.4 and 8.5 are going to round down. Now, I know you're going to tell me that 8.45 rounds up, but it still becomes the boundary where you make the decision about where you want to round up one way or the other. So halfway between 8.4 and 8.5 is 8.45, and the other boundary is going to be halfway between 8.3 and 8.4, which is 8.35. Okay, so they form my two intervals, 8.35 and 8.45. You can see that this one is less than or equal to, and this one's strictly less than, which is why I can use that right hand limit. Okay, 9B, complete the error interval for the perimeter. Okay, so this is a regular pentagon. What does a pentagon look like? It is a five-sided polygon. 1, 2, 3, 4, 5. Okay, so each one of those is going to be between, any one of those sides is going to be between 8.35 and 8.45. Okay, and what we're going to do is multiply those by 5. So what I need to do then is take the lower limit, 8.35, and times that by 5. 8.35 times 5. That gives me 41.75. So that's going to be the lower limit. And then taking the upper limit, 8.45, and timesing that by 5, it's going to give me the upper limit, 42.25. Okay. Question 24. A tank is a cuboid measuring 50 centimeters by 35 centimeters by 20 centimeters. All lengths are in the nearest centimeter, and that has been given in bold, which is normally shouting at the student. This is important. Take note. Okay. The reason it's there is to signal that this is a limits of accuracy question. Unusual, seeing we've already had one so far in the paper. This is the second one, isn't it? Very odd that we should have it twice. But anyway, can imagine a scale with 50 written on it. 1 centimeter above is 51, 1 centimeter below is 49, same as I did earlier. So all the numbers which are halfway between those or closer to 50, round to 50. So our 50 is actually going to be anywhere in there, isn't it? Okay, so which could be as low as 49.5, it could be as much as 50.5. Okay, and similarly, the 35, we do the same thing there, 35, 36, 34, halfway between. It's going to round to 35, so that is 34.5 is the lower limit, and 35.5 is the upper limit. All those numbers round to 35. And finally, 20 centimeters, 20 in the middle, 21, and 19. The numbers that round to 20 are going to be the ones halfway between those, which is 19.5 to 20.5. Right, so we're comparing it to this other container, which is exactly 34 litres. So basically, we want to find the upper and lower bound of this cuboid and compare it to this exact capacity of 34 litres and see what we've got. Okay. So the smallest possible cuboid is going to be my 3 small measurements. Okay, so lower bound volume is going to be 49.5 times 34.5 times 19.5, which is what? 49.5 times 34.5 times 19.5. That comes out to 33301. 33301. Okay, now the upper bound I'm going to get for the volume, it's going to be those 3 at the other end, aren't they? Multiplying those together. So that is going to be 50.5 times 35.5 times 20.5. Again, tapping that into the calculator. 50.5 times 35.5 times 20.5. That comes out to be 36751. 36751. Now these are going to be in cubic centimeters, aren't they? Because I use centimeters. And I know that 1 litre is 1,000 cubic centimeters. If I divide these by 1,000, it will give me the capacity in litres. So this one is roughly 33.3 litres, and this one is 36.7 litres. So our volume then is going to lie between those then, isn't it? It's going to be anywhere up to that or down to that one. Okay, so comparing then with our 34 litres, we can see, our lower bound is smaller than 34 litres and our upper bound is larger than 34 litres. So we can't tell, can we? It could be either side. So I'm going to tick that can't tell box. Okay? Because it could be one or the other. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.